We'll be speaking about extracting meaningful information from US patent applications. Right?
Hi, good afternoon, everyone. So as you can see, the title for my presentation is Detect Novel Semantic Similarity to Extract Meaningful Information from US patent applications. So basically what it means is we are trying to extract whether a particular phrase or a particular term is relevant or similar to another phrase in a particular context. So this project was done under the aegis of Professor Ming, Shao. And moving on, so the presentation will be basically segregated into 4 phases. One would be the introduction, which is happening now. Then I would talk about the approaches which I took, some of the key concepts which I learned and which are applicable to this undertaking, and finally the result and the future scope. So the motivation for this project was purely from an academic standpoint and personal standpoint, was to develop an understanding of ML concepts, especially when it comes to something as niche as natural language processing, and also to hone my skills regarding data wrangling, feature engineering, and stuff like that. Get to know the Python packages which are used, especially regarding NLP. And also, because this was a Kaggle competition, I wanted to get to familiarize myself with how Kaggle submission formats and everything works, and or modify the output accordingly to that. So what are patents? So patents are a form of intellectual property granted in exchange for public disclosure of new valuable inventions. So the thing about this project is that it has to detect and establish what you would call novel semantic similarity, whereas we are not doing a simple phrase-to-phrase similarity. The phrases or the terms need to be similar in a particular context. So for example, let's say we have these 2 terms, bird and Cape Cod. Now they are not similar at all. But let's say if I'm talking about it in the context of scenery, or let's say I'm talking about it in context of house, it can be similar. We can talk about buying a house in Cape Cod or building a bird house. So in that context, it is similar. So why does the US Patent Office need this? Sorry, my bad. Yeah, so basically they have automated quite a lot of processes in terms of the patent pipeline, in terms of ingestion and the dispersal of the patent, but the inspection and evaluation of the patent, it is still done manually. It is still a pretty manual process. So they want to do something along these lines, wherein there are 2 similar patent applications, but one is on a different domain, then the secondary patent shouldn't be declined, or it shouldn't be denied at all. So yeah. So the data set, as I said, this was a Kaggle competition. So the data set was provided by Kaggle themselves, the training data set, that is. And they also had a quote unquote validation testing data set, which had far fewer records than would be required for a validation process to work. And then they had another unseen data set, testing set, against which this would be evaluated. So the unseen test set was not something which was provided or publicly available. It resided on a server. Once you submit your script, it would be run against that testing set to see and give you a final Pearson's correlation coefficient score. So these are the basic features which were there, which were present in the training data set. One was the ID. This is a unique identifier. The anchor, that is the first phrase which you want to test. The target, the second phrase which you are against which you want to see whether there is a similarity or not. The context was given by the CPC classification. The CPC classification is something which the US Patent Office uses for the different domains and subdomains against which a patent application is processed. The score was the similarity score, which I just mentioned would be the Pearson correlation coefficient. So let's give a quick second for everyone to just take a look into it. And moving along. So as I said, the primary method for evaluation will be the Pearson correlation coefficient. And the grades will be given from 0 to 1 with 0.25 point increments for every similarity. So for example, let's say we have something like mobile phone versus cell phone. These are two similar things. But like similarly, we have abbreviation for called transmission control protocol. So mobile phone or something like that, which is for communication and transmitting communication lines. It comes under the umbrella term called transmission control protocol. So if there is a patent for mobile phone and somebody is again filing a patent for a transmission control protocol, this shouldn't be denied just because they fall under the same category. But even though it might be for a different context altogether or a different domain. So moving on, the primary tech stack was Python Jupyter Notebook to be more precise. And the Jupyter Notebook again was provided by Kaggle. The competition constraint was that it had to be run natively on Kaggle. It didn't allow a lot of the things which I'll just talk about, which made it a bit constraining and irritating at the same time. But one of the things that it did have was it had an inbuilt save to Git feature. So I didn't need to save it on my local system and then push it to Git. I could just do it from there itself. So the preliminary approach, which we were earlier planning to do, was do an OLS regression. We do a binary encoding on the anchor value and see and regress it against the score and see how it performs. That didn't pan out very well. Then we did. Then for some reason I thought GPT-3 could be used, and as I said, this was a moonshot. I was planning to do something along how ESRB rates games or movies, and give it like, so like, let's say if you have two phrases which are very similar, you get a high rating if your score is like 1 or 0.75. Oops, sorry. Similarly, then as I carried on studying more about it, I came to know about BERT and Hugging Face interface. And so we decided to go for BERT. BERT basically stands for bidirectional encoder representation from transformers. So transformers especially have been phenomenal and very useful in terms of modern day NLP context, which have led to and are the primary backbone of the things like ChatGPT, for instance. So what set BERT apart from the other models for in this context was that it has the bidirectional training. So basically, it could take both the phrase on your left and on your right, and randomly mask some of the phrases in the entire in the entire sentence, and then you can see whether or not it can detect the similarity or not. And it is very useful for contextual establishment. So that's what set BERT apart. So this is the basic architecture of BERT. So let's say your sentence is something like, my dog is cute, he likes playing something. So it randomly maps some of the phrases, and then it passes it through the embeddings and all. So why did BERT and not GPT? Because BERT can generate embeddings for phrases in the context of the CPC classification. So the CPC classification was the context which the USPTO and the competition required us to do. And BERT is somewhat context aware for that. And it is already pre-trained on a large corpus of text, including the quote-unquote patent words, which basically has all patent applications, not just in English, but throughout the world in different languages as well. And yeah, it also can handle out-of-vocabulary words pretty effectively. So that's a very big thing, especially in this context. Especially in BERT, there was another variant of it. It's called DBERTA, which was developed by Microsoft. It's called Disentangled Attention Enhancement for BERT. It has something called an additional layer of an embedding called relative positional embedding. So a relative positional embedding is particularly useful in terms of context capture, because BERT generally just does it on a hard coded basis, like all the positions are hard coded altogether, whereas DBERTA can just check it depending on the position throughout the sentence, how it is supposed to be in a particular context. And so this is basically what I just talked about DBERTA, and it has 24 layers and it has a hidden size of 1024. And disentangled attention mechanism allows it to selectively attend to different aspects of the input sequence without interference. So the training approach was simple because I already had a pre-trained model. I just had to import the relevant data set and packages, tune the model hyperparameters, basically set the user-defined parameters on how the MLC, the machine learning model would function, do a 5-fold cross-validation with 5 epochs each. And DiBerta was also very useful because it took the least time. So some of the key concepts were the cross entropy loss. So this is a very important concept when it comes to NLP, and this is something which DiBerta and even GPT optimize for when it either generates an output or if DiBerta gives you a correlation coefficient. Now, how is the cross entropy loss optimized for? It is done through stochastic gradient descent. So the more, the higher the learning rate you have, the process may diverge. But if you have a lower learning rate, the process may take very long to converge. And that's what happened with me. Like the training itself took about 6 hours for it to run altogether. Now, these are the key kind of differences between self-attention and disentangled attention. Self-attention is the mechanism which ChatGPT uses, whereas disentangled attention is the mechanism which DiBerta and other BERT models use. And it is very so in this in our requirements, the applicability and the complexity are the most important factors, because the disentangled attention is comparatively less complex and it can be implemented pretty easily. So this was the final result which I got after I submitted it to the server. I got a Pearson correlation coefficient of 0.83. The public score is the mean score. The private score is just it tells you against the small test data set that they provided, but the public score is the one which is the main one. Now, one of the things which was really constraining was how the hardware and everything along those lines. So Kaggle only allows you to 12 hours of runtime, and it has a very limited disk space. So I tried to do a lot of different models, but I kept running into hardware issues where my notebook would fail either because it exceeded the 12-hour runtime or I just ran out of disk space. So DiBerta was the only one which really did give me the optimum results and also helped me with the project. Now, the key learnings for me were obviously getting acclimated with the NLP concepts, understanding difference between BERT and GPT, getting familiarized with transformers and stuff. And improvement, the project can obviously use a lot more in terms of training data, and also because a lot of the hyperparameters which I tuned were tuned on a hit and trial basis manually. If I get to learn something like random search or Bayesian optimization, this can obviously work in a much better way. And also, the comparative studies of different NLP models for this task should be considered, which I tried, but for the reasons I mentioned, couldn't. There are spillover advantages for apps like Grammarly, Discord, etc., to improve their product offerings and stuff like that. And if this slide has been uploaded to my GitHub as well, so do go through it. And you can see how ChatGPT was really instrumental in helping me with this project. But yes, it has a lot of pitfalls. Please be careful of them. Especially I would say the second point really helped me out a lot, because if you're not understanding the response it has been generated, just pass it back into it and say that, okay, you said this, now you're saying this, give me a web resource and explain yourself. So yeah, that has been really helpful. And obviously the last point, incorrect or half-baked input will yield similar output. And please go through my project on my GitHub. Feel free to critique it. And if you want to collaborate or to take it to the next level, I'll be all ears. These are the references. And thank you. Feel free to connect with me on LinkedIn. Any questions?
Hello.
Question, I think. For these pre-trained models, do you have to pay money to get access to them, or time?
Oh, no. So basically, under PyTorch, you have the transformers package. It is basically provided by Hugging Face itself. You just load it and you train the tokenizer, and it can just import.
So like Berta, for example, is part of PyTorch.
Yes. Yeah. So you didn't need to pay for it, but at the same time, there were constraints from the competition that you cannot do API integration. So first I tried to do it with an API integration where I had the Hugging Face interface there itself and tried to train the model. But when I submitted it, it failed because the competition didn't allow for it.
Thank you. Any other questions? All right, let's take this one.
Thank you.